Welcome students. As you know, we are studying about electrical capacitance and combination of capacitance. So first type of combination is over. Now see the conceptual points of second type of capacitor. Let's suppose your capacitor is as like this, okay, and it is filled by dielectric constant what? K. So what is the formula? C is equal to Ka epsilon naught upon D. D is the distance between plates and A is the area of plate. Okay, this is already taught. So this is the first type of capacitance. Let us suppose in same capacitance we filled only one dielectric constant is here. If between the plates we fill two different type of dielectric constant, and it could be filled in three ways. One is in series, another is in parallel, and third is in mixed combination. Let us suppose for that portion we filled dielectric constant K1, and in that portion filled the dielectric constant is what? K2. In first portion we had filled only one type of dielectric constant, while in second portion we are filling two different type of dielectric constant. As like in first half portion we filled wax, another in second half portion we filled what? Mica. This is parallel plate capacitor, you better know. So it's a distance, area is remaining same. Keep in mind, this is conceptual point. If area remaining same and you are cutting the distance, here distance was D, here distance divided in two parts, it become dy2 and it also become what? dy2. Keep in mind, if area remain constant and distance is divided in two parts, this is called series combination. Are you getting? Very important point. If distance is dividing in three part, in two part, or in four part, but area never change, area remain constant, this is called series combination. First point, this is first. Second one, if for that capacitor you are cutting as like this, see there, distance is D and you fill dielectric constant here K1, and here dielectric constant is what? Dielectric constant for that portion is what? K2. Distance remains same but area become A by 2 and A by 2. This is called parallel combination. Are you getting? If distance divided, area same, this is called series combination. If area divided, you are filling dielectric constant as like up and down, here K1 and here what? K2. It means area become in two parts, A1 and what? A2. So half of A1 by 2, A1 by, or A by 2, A by 2, but distance remain constant. In that type of case you have to apply the parallel combination. Are you getting? Third type, let's suppose you are given as like this, some more complicated. First you cut this and second you cut this. It means three different type of dielectric constant are filled. That is called K1, this is called K2, and that much is called what? K3. We can fill as like this. This is third question we can do. So here you can see here distance become half and half, distance divided D by 2 and D by 2, because you better know distance was D, it become D by 2, D by 2. Here distance is D, okay, but area you are cutting from here, area also D by 2 and D by 2. So no doubt they are in series but they are in parallel. So this is called mixed combination. Are you getting? That was your original capacitor. Formula was C is equal to Ka epsilon naught upon D. We can combine this capacitor in different three ways. If distance divide, area remains same, this is called series combination. If area divide, distance same, this is called parallel combination. If both divides, area as well as distance, this is called mixed combination. Okay. So this is the all three cases, case number 1, case number 2, and what? Case number 3. This is the conceptual physics for this topic. Okay. Let us suppose you are given a question as like this. This is given you in different books. Let's suppose you are getting as like this, and that much portion is filled with K1 and that much portion is filled with what? K2. And I ask find the equivalent capacitance. So no doubt first you see there what disturbance is created here. Here area you see there, it is filled as like this. So area is A by 2 and area is A by 2. While distance remains same, D. So no doubt they are in series combination. Sorry, they are in parallel combination. That just I taught. Okay. So what a formula for C? You better know C is equal to Ka epsilon naught upon D. You better know the formula. So what will be C1? You find out the C1 and C2 in two different ways. So C1 is equal to C1 is equal to what the value of K? K is what? K1. A. What is A? A become A by 2. A upon 2 epsilon naught upon what the distance is same upon D. Are you getting? This value modify as a C1. What the value of C2? C2 is equal to K2A epsilon naught upon same thing 2D. Same thing here K1 and here what? We are getting K2. Distance is same. Area become A by 2. In the place of A, we written here A by 2. Epsilon naught upon distance remains same. Distance is only D. Now, as I said, if area divides, they are in parallel combination. So C1, C2 are in parallel. So we can write formula C dash is equal to what we get here? C1 plus C2. You better know this is the formula of parallel C1 plus C2. So what we get here? C dash is equal to what the value of C1? K1A epsilon naught upon 2D plus what the value of C2? K2A epsilon naught upon 2D. C dash is equal to A epsilon naught upon 2D is common. A epsilon naught upon 2D is common. What are inside? We get K1 plus what? K2. But we know that A epsilon naught upon D, that is the parallel plate, formula for parallel plate capacitor. So we can write it C. So formula C dash is equal to C upon 2, or you can put as like this. Okay, so it becomes C by 2. C by 2 and inside what? K1 plus K2. Are you getting? So this is the answer for you. So this is the second type of combination of capacitors by which you can do many numericals. Some are given in SC Verma as well as in your some NCERT or in different books. So okay, so these are the points on which you have to work. In same way, you can find out some conceptual question or some assignment for you. Next, you have to find out the capacity for this one. You try for this. It is as like this. It is K1 and K2. What will be the C dash? You have to find out. Next, you cut from here K1 that much, K2 and that much what? Come on, K3, and you find the formula for C dash. So this is the homework for you. You can do on same way what I taught. Okay. So this is all about your combination of parallel plate capacitor in different way. Okay. One more question is there. One more third type of capacitance combination. Let's suppose you are given as like this. This question is given and it applied 500 volt and all have a value 10 microfarad capacitor. Let's suppose these are 10 microfarad, 10 picofarad. I ask find the capacitance between AB and potential capacitance between AB. It means CAB. What is potential V for each one and what are the charge for each capacitor? That is our question. You have to divide the potential as well as charge in different manner. So first what you have to do, you solve it in a complicated circuit into isomer one. So you better know all three are in series. First all three 10 are in series. Okay, so 10, 1 by 10 plus 1 by 10 plus 1 by 10, it become very easier as like this. So 10 by 1 by 10, 1 by 10, it become 10 by 3 and this is what? 10. This is 10 and it is connected through how much volt? What? 500 volt, very easy. Okay, now they are in parallel. So what are the next one? So capacitor, equivalent capacitance C dash is equal to parallel C1 plus C2, the 10 plus 10 by 3, it becomes C dash is equal to 30 plus 10, it become 40 by 3 microfarad. This is the first answer for you. Are you getting the point? Okay. Now, what will be the charge? Total charge was Q, it become as a Q1 and what? Q2. So what are the value of Q? Q is equal to, you better know Q is equal to CB. So Q1 is equal to C1 into V. So Q1 is equal to C1. What are value of C1? C1 is given here. 10 by 3 into 10 power minus 6 into what are potential? You better know. In parallel, potential remain constant. So its potential will be 500 volt. Its potential will be again how much? 500 volt. So what are formula for V? 500. Now you calculate. So this will be the value of Q1. So you can write here Q1 and Q1 will be same because they are in series combination. Keep in mind They are in series combination. So by that formula you can calculate and get the value of what? Q1. Similarly, what the value of Q2? Q2 is equal to C2V. What the value of C2 here? So Q2 is equal to, the value of C2 is given what? 10 into 10 power minus 6 into what a potential? Again we know the potential. Potential is what? 500. Now again you can calculate the value of Q2, and Q2 will be on that way. Since all three are in series, so all have a same charges Q1, Q1, Q1. So charges will same. Here charge will be Q1 and here charge will what? Q2. What are the potential? Its potential is, you better know, its potential is how much? 500. Its potential is again 500, which is divided into three equal parts. Keep in mind. Otherwise, Q is known, C is known. You can find out the potential as like V is equal to what? Q upon C. Q is same for all, and capacitance is same again, 10, 10, 10. If capacity are different, potential will different. You will assume as a C1, C2, C3. But here condition is very easy. So what are potential? Total potential was 500. You better know total potential was 500. It divided in three equal parts because in series potential is different. But since capacity is same, so its potential will be same. So its potential become 500 divided by 3. Its potential become 500 upon 3. Its potential become 500 upon 3. Its potential become 500 upon 3. In this way, we can solve the complicated question. Once again, that was your question. First, you solve the complicated into year 1. First you get the value of what? Equivalent capacitance. Then by equivalent capacitance, you go through conceptual points. Since they are in parallel, or you better know in parallel, potential remain constant. So potential is constant. So total potential was 500. Its potential is 500. Its potential is again 500. And since potential is known and capacity is known, so you can find the value of what? Q1 and what? Q2. Again, back to pavilion or original question. Since this 500 is the addition of all three, and they are in series, and you better know in series capacity are different. But one thing is very good, since their capacity is same, so potential equally divided in three parts, and that is 500 by 3, 500 by 3, 500 by 3. If you add them, you will get 500, no doubt. And similarly, its potential is 500. So we can find out the Q1, Q2, V1, V2, V3, so on. Okay, so that's all for that question. One more question is given in your NCERT example. So you can do this by that method. Okay, that's all for today.